All right, some equations and some situations involve radicals, and right triangles is one of them. So we've got a right triangle with a hypotenuse of 18, and one leg is 9 root 3. So I'm just going to draw a picture for that. And then we're finding the other leg. So we'll use the Pythagorean theorem. And x squared. 9 root 3 is 81 times 3, which is 243. And then 18 squared is 324. Just subtract 243 from both sides. We would have x squared equals 81. Let's take the square root of both sides. That's where radicals come in again. And we get x is equal to 9. Now, technically, this would be one of those situations where we would need to use the absolute value of x equals 9. But we can't have a negative side length. So it's not really possible in this situation. All right, so the side length is 9. I'm actually working with my daughter right now on special right triangles, and so maybe from your geometry class you might remember 30, 60, 90s, in which case you might not have even have done any work when you recognize those two and you just knew that that would be 9. Again, that was 30, 60, 90 triangles. Distance formula. That distance formula has a square root in it. And so that's what we're looking at here. So our formula, x2 minus x1 squared plus y2 minus y1 squared, would tell us the distance. So let's do the square root of 1 minus 5 squared. That's x2 minus x1, and negative 2 minus 6 squared. That's y2 minus y1. 1 minus 5 is negative 4, so we've got negative 4 squared. Negative 2 minus 6 is negative 8 squared. And then that's going to be negative 4 times negative 4 is 16. And negative 8 times negative 8 is 64. We add that together. 16 plus 64 is 80. So we're looking at the square root of 80, which does reduce a little bit. So that would be 16 times 5. So the square root of 16 times the square root of 5. Square root of 16 is 4. So 4 root 5 is that distance. Most of my time teaching early in the career, I was teaching geometry, and I always really like to look at this actually differently than just the distance formula. I actually would have preferred often as a geometry teacher to think about the distance. That's something you could find by using Pythagorean theorem. And the vertical distance here is 8 in that triangle. And the horizontal distance here on this triangle is 4. And so we would have 4 squared plus 8 squared, which would be 16 plus 64. And that would allow us, using the Pythagorean theorem, to figure out again that that would be square root of 80 or 4 root 5. Okay, but the distance formula obviously would work as well. Just a couple more problems here. Subtracting imaginary numbers, actually complex numbers. We want to work with the real part and the real part, the imaginary part with the imaginary part. So 5 minus 8 is negative 3. And we have to remember to distribute that negative as well here. So we've got negative 3i minus, well, change it to a plus a negative 4i. So negative 3 minus 4 is negative 7i. So we put the real part with the real and the imaginary with the imaginary. Remember, the a is the real, that's the imaginary. So when we're combining or subtracting real with real, imaginary with imaginary. Okay, multiplying. when we're multiplying, we can't think of it just as real times real and imaginary times imaginary. We have to think of this as a binomial times a binomial. So we're going to multiply the first times the first. That's 40. Then the outer, that's going to be plus 20i. The inner, minus 24i. And then the last, negative 3 times 4 is negative 12. I times I is I squared. Well, I is equal to the square root of negative 1, so I squared is equal to negative 1. So we're going to replace that I squared with a negative 1. 40, combine these like terms, minus 4i, and then minus 12 times negative 1. Minus 12 times negative 1 is going to be a plus 12. So 40 minus 4i plus 12. 40 plus 12 is 52 minus 4i. We usually try to get our answers in a format of this a, the real part, plus bi, a being 52, bi being negative 4i. That's multiplying. So adding, subtracting, we're combining the real part with the real part, the imaginary part with the imaginary part. Multiplying, treating it like a binomial times a binomial and distributing like that. Dividing, we have to use that idea of the conjugate. And the conjugate goes to that very common thing we've seen in this class, the a plus b, a minus b pattern, which is going to help us eliminate any imaginary numbers or imaginary pieces of our denominator. So if 2 minus 4i is the denominator, we're going to multiply by 2 plus 4i, its conjugate, on the top and the bottom. This is just a fancy version of the number 1 here. So we're going to, on the bottom, we'll just do it separately. Let's do the numerator over here and do the denominator down here. So we're going to have 2 minus 4i, 2 plus 4i. If we use that distributing idea, we'd have 2 times 2 is 4. I'm not going to write it, but 2 times positive 4 is positive 8i. Here we would have negative 8i. That'll cancel to 0. Negative 4 times positive 4 is negative 16. I times I is I squared. We know I squared is negative 1. So that is 4 minus 16 times negative 1, which is going to be 4 plus 16, which is 20. So our denominator is just going to be 20. The numerator, we're going to do 3 times 2 is 6. 3 times 4 is 12, so 12i. Inner, 2i times 2 is 4i. And then 2i times 4i is 8i squared. And then, so that line, those will combine to be 16i. That's 8i squared is going to be 8 times negative 1, so minus 8. So 6 plus 16i minus 8. 6 minus 8 is negative 2 plus 16i. So that's our numerator. That's our denominators down here. So we'll put it together. We would have negative 2 plus 16i over 20. Is there anything that would simplify? All of these can be divided by 2. So we would have 2 times negative 1 plus 8i, and then 2 times 10, and then those 2's cancel. So final answer, negative 1 plus 8i over 10. Okay, so that was subtracting, multiplying, and dividing radical numbers, or sorry, complex numbers.